at midnight. At midnight. Okay, any problem of the Alex, the student has some problem with the Alex. I don't want to solve it now. You email me or when the class is over, you stay, right? That some student email me, I don't know the code, I don't know something. Well, no. Replace, okay, This is the problem. The code sometimes have O, and maybe it's no O, it's zero, but don't worry, no, after. I don't want to talk about this now. No. Entonces, everything is clear. O sea, September 29, 2020, we start new chapter. I don't want to see any more test number one. Test number one on paper. I collect this day at midnight the due day, and test online. Homework also, right? Online. Yeah, great. Maybe this day is Tuesday, no? You see in the calendar, 29 is Tuesday, no? Let me see. It's Tuesday. So I grade maybe Wednesday. Or I don't know. Depends if I am busy. Okay, everyone understand very well the idea? Are you happy? Are you happy? Are you happy? Good. Excellent. Right? Happy?
Yes, sir. Very happy. Thank you.
No problem. Okay, one more thing. One more important thing. I would like, please, when you write on the paper the answer of the test, you write clear. You write organized. Okay? Like a real test. No, because see, I don't understand your answer, I grade zero. Clear that you recommend solving, depending the question, si es too long or no, in one page, si es not too long, one you say, divide the page, question one, question two, okay, pero clear that you are advanced student, you are not kindergarten student, okay? Okay, good. Entonces, today, I would like to continue working with the rational function. Therefore, we are doing, my plan is doing three problems in which you analyze everything. You see the board? You see the board?
Yes, sir.
Okay. Okay, this is my example. I call example 5. I don't know if you receive or no the si you receive or no the one email que I sent to you the information of the Desmos, no? The link connected with the Desmos, no? You receive or no? Yes. Okay. So this is when you open this Desmos and example number 5 is this. Okay. So I explain step by step what is the guideline to do the graph, because the question is do the graph, no? Of this. And you know this graph is a little bit complicated because we have a lot of things. We have vertical asymptote, horizontal asymptote. So what is the correct order? The correct order is number one step is do the factorization of this. Well, in this case, you express the original function in factory form. In the top, bueno, we have monomial, stay the same. But in the bottom, we have binomial, but this binomial is a difference of a square, and you factorization like that. Plus and minus. Correct? It's important this step because if we have a common factor, this is 2. This is a moment to cancel out, eliminate the factor, the common factor. And this common factor gets gone is a whole. But in this case, we have no whole. We have no whole. Because I can see that there are no common factor. We have no whole. The second is compute the y and z. The formula to remember for any function, not only for the rational function, is you evaluate the function as 0. So replace x for zeros. 4 times 0 divided by 0 squared minus 4. 4 times 0 is 0, divided by 0 squared is 0, is minus 4, and 0 divided by any number is 0. Therefore, the point is 0, 0. It's the origin. And when this situation happens, when the y intercept is the origin, it's because this intercept is both as x and y intercept. But be careful, because maybe in this example, no, but in another example, maybe yes, we have another extra x intercept. So the third step is find the x intercept. And the formula is f of x equal to 0. Look, it's only, in my opinion, the mnemonic divide to remember the formula of the y-intercept is this, and the mnemonic divide to remember the x-intercept is this. And you solve in this equation. Okay, so I copy that. I copy that again for x over x squared minus 4 equal to 0. Then when you have a fraction, a over b equal to 0, is because a is 0. I don't care b. B is not important. So the top part is 0. So the responsibility to be 0 is the top part, always. So you can reduce this equation and this equation. Divided by 4, both sides. X equals 0. And we come back again to the same. So it's a coincidence. In this example, not always. 0, 0 is both. Is x in a set and y in a set. Everyone follow me, or you are totally lost. Clear?
I'm clear. Thank you.
Okay, super. Number 4 step. I want to memorize in this order, guys. And number 4 is compute the vertical asymptote. And the vertical asymptote is the 0. Remember, in any rational function, f of x is equal p of x divided by q of x. The vertical asymptote you obtain when you, after the factorization and simplification, the common factor, because the common factor represents wholes, the bottom part remain, get q, you put equal to 0. Okay, and this is the formula to get the vertical asymptote always after the simplification. In our specific example, anyone make group chat for this class? I don't know. Okay. Let's continue, guys. You take the expression in the bottom, get this. Oh, attendance, don't worry for the attendance. Because when you get in Sky, automatically Sky write in its background your name. So I check in, that's it. Okay. I am a teacher. You only pay attention and try to understand mathematics. The rest, attendance and connection is another problem. Equal 0. So equal to 0. You put the denominator equal 0. You write. Some people prefer writing that way. And other people prefer writing that way. I don't know what is better to you. So you write like original expression, or the factor form. Either way, because suppose yes, a factor form is pretty easy. You separate in two linear equations, and one solution is -2, x equals -2. Another solution is +2. Entonces, this is our set of the vertical asymptote. Another student say, well, okay, I don't like this way. I like that way. You consider this like a quadratic equation. You solve for x. You move forward to the right-hand side like a positive. Apply square root both sides. And x squared square root 4 is 2. but don't forget plus and minus, and we get exactly the same answer. But actually, we have two vertical asymptotes, -2 and +2. So when you are doing the sketch of the graph in the paper, or I recommend doing in the decimals, no? 1, 2, 1, 2, +2, -2. We have two on black color, dotted line. This is the vertical asymptote number 1, and this is the vertical asymptote number 2. We have also, by the way, the origin, que es 0,0, que 0,0 is y and x intercept. This is the x-axis, and this is the y-axis. Okay. This is no super important, because after we are doing decimals. Everyone follow me? Everyone understand vertical asymptote? How you find vertical asymptote? Always is the same. No problema.
Yes, Professor. Go.
Okay. Go ahead. No problema. Super clear. Hey, I need to understand your problem. No? Yes? Communication. What happened? What's going on?
Yes, sir. No, we're good, sir. I understand.
Okay.
I understand.
Number 5 now. Number 5 is you try to find a combination horizontal asymptote or slant asymptote. And remember, I say only one possibility we have, because this situation is completely mutually exclusive. So you have horizontal, you have no slant. So you have slant, you have no horizontal. But both is impossible. Okay? And remember, we are doing the analysis of the degree. This is the degree analysis. Always the same. I want to recall this idea. I remember we have horizontal in two possibilities: the regular case and the special case. Regular is when the degree is the same. The degree of P at the top is equal degree of Q. Same degree. This is regular. And we have, yes, of course, absolutely, we have horizontal. And we have another special case when the degree of Q is greater than degree of P. In this case, it's special because it's y equals 0. In this case, no, it's y equal any number, and this number depends on the leading coefficient in front the higher degree. I suppose you remember very well this idea, yes or no? In our specific example, I can see that the degree of the top is 1, degree 1. Linear polynomial, and the degree of the polynomial in the bottom is 2 quadratic polynomial. Therefore, we have a special case of the horizontal asymptote. Yes, the answer is yes, we have horizontal asymptote at y equals 0 because it's a special. And immediately, using maybe black color dotted line, I do the horizontal line like that. Okay. The equation, let me see to understand very well this part. The equation for this vertical asymptote was x equal 2. The equation for this was x equal -2. And the equation for this horizontal asymptote is y equals 0 because the horizontal line. And it's a perfect coincidence with the x-axis. And immediately, automatically, I don't know why the student forgot this moment. You need to determine if the curve crossed or not the horizontal axis. To determine this, you take again the original equation, the original function, sorry. and you enforce it to be equal the value of for the y, let's say que and one more time, we get this equation that we solved before. When we solving the x intercept. So what is the conclusion? No, the conclusion is the famous point 0,0 is three things. Is 0,0 is three things. It's y in a set, xx in a set, and also it's the famous point when the curve crosses the y-axis. I don't know exactly, but here the curve crosses like that or crosses like that. I suppose que crosses, not touch. Cross. Okay, it's the famous point when the line crosses. Now, well, we almost finished. We almost finished. Step number 6, extremely important, extremely important, and the student forgot. Number 6 is determine symmetry. What is important symmetry? Because see, you prove somehow that my function is even means that when you replace x for negative x, the function stays the same. That means that my curve is symmetric with respect to the y-axis. Like that. Boom, 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 boom. So, you don't need to compute both sides. You compute, for example, the positive part because I know that the negative part is completely symmetric. Si you prove que sí. Si eso is similar, no? You replace x for negative x is minus f of x. So the graph is symmetry also, but in different way, like that. Boom, 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 boom. So when you have x, you give me y, but when you have the same value of the x, but opposite sign, you give me opposite value of the negative one. This is symmetry with respect the origin, and this is symmetry with respect the y-axis. And this is symmetry with respect the origin. And this is useful because when you prove somehow, let's see in this example, get useful. Si es neither, well, unfortunately, we have no symmetry. Entonces we need to do the graph of the negative part and the negative part completely separately, independent, because we have no symmetry. Well, I cannot take advantage of this property. Okay, let's prove quickly. This is my function f of x, que es 4x divided by x squared minus 4. Entonces, in order to prove que es even, odd, or neither, you replace x for negative x. So because in the top state minus 4x, in the bottom no, because negative x squared is stay positive, minus 4. When you compare this equation and the original equation, you see it's similar, very, very similar, except if we have extra negative one here. Okay, by the way, we can write this negative one if you want to see much better, more clear. You write no here in the top, you write in the middle like that. It's the same, right? Therefore, es obvio que our function is odd function. Remember, odd function is the function when you replace x for negative x, now you obtain similar expression, but the negative in the front, like that, negative in the front, like that. It's odd function. And this is a specific example. Another example, I don't know. Odd function. Okay, since odd function, then I want to study only the positive part because I know that the negative part is symmetric, pero symmetric with respect to the origin, of course. Okay, entonces number 7, que es the last step. It's too long, I know, sorry. This is not kindergarten algebra. This is pre-calculus. You take additional points. Additional points to complete the plot. How many points? Depending on the example. There are no rules. Okay, let me try to understand this. How many points I need, and at least in what interval I need to select. So our graph look like that. Look, so far. Let me change the color to, I like this color. Okay, it's like a rainbow. Okay, and see, I see the x-axis you have in 2 one vertical asymptote. In 0 we have intersecting point. In 2 we have another vertical asymptote. This vertical asymptote and this point create like a partition, no, of the x-axis. So for example, I propose you select one point here, maybe 3 is good in this region. One here, one, and that's it. If you want to select one more, it's okay. In my paper, I select 4, but this is important. I don't need to select -1 because a -1 and +1 have similar behavior. So suppose that when I plug in 1, the answer is 3. When you plug in -1, the answer is -3 because it's symmetry with respect to the origin. And -4, exactly the same. Let's do it. This is the easy part, of course. This is just plugging in into the formula. And of course, you can use a calculator, no? Plugging in 1 here. Entonces 4, 4 times 1 divided by 1 squared minus 4. The answer is -4/3. Entonces we have a point que es 1, -4/3, and we have another point que es -1, +4/3, because I take advantage of the symmetry, que es odd function. Let's do it, for example, 3. Exactly the same. It's 4 times 3 over 3 squared minus 4. This is 12. This is 9. Minus 4 is 5. Is 12/5. And we have a couple of points also, que es 3, 12/5. 12/5 is 2.4. You want to express it in decimal, it's better. 12/5. And -3, minus 12. To plot the point, I really strong recommend using decimal. No, for example, this point is a point 1, 1.3, -1.3. We repeat it, no? You put in the calculator 4 divided by 3, 1.3 repeat. And here is exactly the same value in decimal, and this is 3, 2.5, 2.4. Negative, positive, and negative. Okay, enough. In this case, 2 points, it's enough. Because we have 2 intervals and I take advantage. And so you have no question, because I would like to go to decimal to see what is the final conclusion, what is the final graph, no? I can switch it or no? Switch it to decimal? Yes, no, yes.
Yes, you may.
Okay, very good. Do you see decimal now or no? No?
Yes.
Yes, okay, good, very good. This is example 5, look. Let me make it zoom. Why not put the projector mode to see more clear? Okay, basically we have, let me explain quickly. I can see, this is the famous point 0,0, okay, it's both x in S, y in S. We have 2 vertical asymptotes, and +2 and -2. I line that way, guys. Black color, dotted line. We have one horizontal asymptote here. Is y equals 0. One more information. The point. This is the point 1, 1 point something, 1.3 repeated. The other. Do you see the symmetry? The symmetry is clear. Look, it's typical odd function because 1x positive give me a negative value maybe, and the same value, but opposite sign, the -1, give me the same y value, but opposite. This is typical of function. Any question? Any question? The student can have clear? Super clear? Confusing? Confusing, very confusing? Okay. Oh, clear. You see the board now or not yet? Not yet? Oh, let me see. Wait a second. Cancel. Share screen. Stop sharing. Okay, the board now. I go to the board now. This is the board. You see the board? Huh?
Yes.
Okay. Let me erase everything. And we are doing number 6 problem. Number 6 problem. Number 6. Number 6 is similar. Is G. Is the name of the function. Is equal. 2x squared minus 3x minus 5. And the bottom we have x squared plus 1. Guide me. What is the first step? Factorization. You need to do factorization at the top and factorization at the bottom. 3, 2. 3, 2. Let me see. No. Okay. Let me try to do the factorization in this corner. I am doing it in weird way, guys. I don't know if you factorization like similar to me, but I like this way. You multiplication this number and this number, get 10. And you try to find the factor, in this case 5 and 2, because I know that 5 times 2 is 10. It's somehow 5 minus 2 is 3. So you replace, this is by grouping, minus 5x plus 2x minus 5. So this expression, it contains 1, 2, 3, and 4. It's equivalent to the trinomial, the original trinomial contains 1, 2, 3. But this is easy by factoring by grouping, no? The greatest common factor in the first couple is x. And the greatest common factor in the second couple is 1, because we have no common factor. So again, I can see that 2x minus 5 is factor, and x plus 1 is the factor of this. So my function g of x in factor 4 is 2x minus 5, x plus 1. But do you understand very well this or no? Okay, don't worry. Si you don't like, you are doing in your own way. The way that you learn in college algebra or in elementary algebra. And what do you suppose can happen in the bottom part? X squared plus 1. Factorization this. Is possible or impossible? It's possible or impossible?
It's possible, Professor.
No, it's impossible. Okay. You need
But
to
you have to
remember.
have the square of both, right? So you have a negative and a positive?
No. This situation happens if you have x squared minus 1. You can apply difference of a square. Like that. Plus or minus. This is okay with this, but this is no. This is impossible. This is irreducible. Why? Because the factorization in this guy is only possible doing in the complex field. Like that. X, I, plus or minus. This is the factorization of this. But I don't care now this factorization because we are working only using real number. And so when you see that, when you see a binomial, and this binomial is squared, degree 2, but it's plus, this is called irreducible quadratic expression. You remember this or no? Yes or no?
Yes.
Or no? Oh, you remember. Of course you remember. Irreducible quadratic, impossible the factorization. Okay. So I did the first step. The second step is compute the y and z, plugging in 0. So 2 times 0 minus 5, 0 plus 1, divided by 0 squared plus 1. And the top we have negative 5, multiplication by 1, divided by 1. So GN0 is negative 5. Therefore, our famous y in a set point is the point 0, negative 5. Everyone follow me? See?
Yes.
Yes. Super. Now let's go. What is the next step? I don't remember. X in a set. What is the formula for the X in a set? This is the formula for the X in a set. What is the formula for the Y in a set? This is the formula for the Y in a set. Okay? So you take the original expression. I don't know if it's good for you. I suppose it's better doing in factor 4, so 2x minus 5, x plus 1, divided by x squared plus 1 equal to 0. Yeah, I know that this is equivalent to say only the top part is 2x minus 5 equals 0 and x plus 1 equals 0. Yeah, I don't care that part. That part is completely irrelevant. And you solve for x, both elementary linear equation. 2x equals 5, x is 5 over 2. If you want to see much better in decimal, it's 2.5. Therefore, the point 2.5, 0 represent x in a set. Likewise, the second equation is x plus 1 equal to 0, x is equal to negative 1, and the second is negative 1, 0. So basically, this problem have one y-intercept and two x-intercept. So this is the point when the curve crosses the y-axis. And this is the point when the curve crosses the x-axis. Keep in mind this when you are doing the graph. So far, everyone follow me? Okay, what is the next step?
Yes, Professor.
Please, go ahead. You
No,
have a question?
I'm following you.
Okay. What is the next step? Help me. In the guideline. I need to organize the work. What is the next?
Vertical asymptote.
Eso, bueno, very good. Very well. And what should I do? What should I do to find the vertical asymptote always? What is the formula? What is the formula to determine vertical asymptote? Is you take what polynomial you take? Top polynomial, bottom polynomial? What polynomial you take in order to find vertical asymptote? Bottom, right? X squared plus 1 equal to 0. But you see before that this is a only imaginary solution. Therefore, the conclusion is when you in algebra, you try to find something and you get complex or imaginary, it's because we have no vertical. Imaginary and complex are like a ghost. Do not exist in our real dimension. When you are doing the graph, x and y. And this x and this y both are real numbers. Real, r squared. Real in the x, real in the y. No complex, no imaginary. So this do not exist here in that plane. No. When you try to find something in algebra and you get imaginary or complex, okay, by the way, it's similar, no? It's because do not exist. Okay? Much better for me. Number 5 is horizontal, no? Or slant. Remember, to analyze this, we need to analyze degree of the polynomial and the competition of the degree. The competition of the degree. Okay, I copied the original again. What do you think? We have or no? We have or no?
They're the same.
Exactly. The same degree, degree 2 and degree 2. Excellent. It's the same. Then we have. Super. Ahora, where? Where? At what value?
2.
2. And where come from these two? Where come from these two? What's the division? 2 divided by invisible one that we have. Que es the coefficient in front, the higher degree. The higher degree, no, the higher exponent, que es the degree. Entonces, y equal to. Yes, we have. Slab, no. Horizontal, yes. At y equal to. Now, immediately you find out, you need to prove somehow if the curve crosses or not. Crosses that horizontal. Okay, let me try. So you take the original function is 2x squared minus 3x minus 5 divided by x squared plus 1, and you enforce it to be equal to, because I want to find if it's possible or impossible that this function crosses the horizontal line, que I know que horizontal line, que es like that, tac, 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 es horizontal, no? Si crosses or no. Okay, so you enforce it to be equal to, and now I propose you for solving this equation, you apply cross multiplication, you multiply this trinomial times 1, que es 2x squared minus 3x minus 5, and 2 times this, 2 parentheses, x squared plus 1. You apply distributive property in order to eliminate the parentheses. Entonces, in that moment, I have equation. What kind of equation? Well, I suppose que es quadratic equation, but actually it's not, because this and this is canceled, and stay alive only minus 3x minus 5 equal to. I move 5 to the other side. It's a linear equation now. 2 plus 5 is 7. Divided by negative 3, because I want to solve for x. X is equal minus 7 over 3. Okay, by the way, this is approximately, well, approximately equal negative 2.3 repeated, no? Entonces we have a point. Yes, we have a point. We discover mathematically, we prove que this function crosses this line, que es horizontal, at the point negative 2.3, comma something. Who help me to write the y component? What is the y component in that case? What is the y component in that case? What is the y component? Help me. Here.
Negative 2.3.
Negative 2.3, no. Negative 2.3, comma. This is the x value, x component. And what is the y component here? Of the famous point in which this curve crosses the horizontal y equal to?
Negative 7 over 3.
Say again?
Negative 7 over 3.
No, 3. Wow. A ver, let me try to understand what should I do? What are doing? We have in 2, one horizontal asymptote. And the curve, I have no idea. I do in decimal, but it's something like that. I discovered at this point is at x equal negative 2.3. Actually, it's negative. The sketch is not good, but this is not important. When you represent this like an order pair, it's negative 2.3, comma 2, because the y component is exactly the same value of the asymptote. Yes or no? Makes sense or stupidity? Eh?
No, yes, both of it.
Ah,
The negative and we get that.
exactly. Everyone follow me? Everyone understand very well the thing we are doing? Okay. What is the next step? According to the guideline methodology to do the graph of this. What is the next? What number is? Number 5, horizontal. And determine the point they cross. In this case, yes. Number 7, symmetry, no?
Symmetry.
Eso. Symmetry. What do you think? In the top, let me see. The original function was g of x is equal to x squared minus 3x minus 5 divided by x squared plus 1. If you replace x for negative x, let's see what happens. 2 negative x squared minus 3 negative x minus 5 negative x squared plus 1. Everything que contain square stays the same. It's 2x squared. But this no. It's a change. And the bar stays the same. And when you compare this new expression and this expression to here, my question is the same? It's exactly the same. They are twins brother. Yes. No, not twin brother. This is a negative, and it's a positive. Si es not twin brother, entonces no even. It is not even. Do you understand or no? O sea, should be saying what definition for the even is when the function is identical. Doesn't change. It's obvious que it's no. And it's odd when you are doing the reflection, it's opposite sign. Do you think it's completely opposite sign? Okay. Answer to me. Is identical as even? No. Is completely opposite sign? No. Of course no, because they are term is positive and another is negative. No. So what is the conclusion? Is nor even nor odd. It's neither. Si es neither, well, okay. Si es neither, the only disadvantage is that we need to do the positive part and the negative part completely separately. And that's it, right? We have no symmetry, therefore we cannot take advantage of this property, no? Guys, do you understand very well this or no?
I'm
following.
It.
It just takes a little more practice.
Okay. No, of course. You have to practice. The thing is that you understand the theoretical part. And so you understand, you will be able to apply this theoretical part in the specific example. Can you face in the future, no? Okay. What is the last part? What is number 8 topic? What is number 8 point? And the guideline, what should I do? Additional. Exactly, additional. How many additional points? I have no idea. But so far, I discovered, this is my all real number line. This is X axis. All real number, infinity positive, infinity negative. I don't care Y axis because I want to see the partition. I discovered, remember, that this is 0 and 2.5. This is 2, this is 3. 2.5 here. We have x equal 2.5. We have 1x in a set. I suppose you remember that. And also a negative 1 here. We have another x in a set. Okay. And also we discover at 2.3 3 repeated. Is -2, -3, -2 here, -3 here. However, here in x equal -2.3, we have the famous point in which the curve crosses. Look at that. Where symmetry here. There you go. So actually, analyzing the all real number line, we have one partition. No, this is dotted line is no vertical line. Because actually, you know that we have no vertical line. This is so we have like 1, 2, 3, and 4 intervals. We have 3 partitions. We have 4 intervals. So I propose you selection in each interval at least one. In my paper, I select, for example, here, I select 5. This is additional. And between 2.5 and -1, you select 0, 1, select 0. I did before, okay, it's -5. But select another, suppose 1, here. And here, suppose -3. So this is more or less the criteria that we're using of the selection of the point. This is the minimum point. And you evaluate in the original function 5, you evaluate in the original function 1, and you evaluate in the original function -3. And you plug it in, I did that. This is just arithmetic. I use my calculator, of course, and the answer in 1 was -3. The answer in 5 was 1.15, and -3 was 2.2. The point that we plot is the point 5, 1.15, 1, -3, and -3, 2.2. Okay, this is just plugging in 5, 1, and -3 into the original equation. And using the calculator, of course. I don't care the arithmetic part. I suppose that you know that. Ready and now. Put everything together. Everything together is, let me recall quickly.
We can't hear you.
Yeah, I can't hear him either. He said he's gonna put everything together. I think his computer froze.
Thank you.
No.
Thank you. I appreciate
Oh,
it. I don't
there
know
he
why
is. Okay.
sometimes disconnecting them. Do you hear me now? Good. Thank you.
Yes, sir. Yes, sir. We hear you.
Now, you see a board now? Now,
Yes.
I discovered that we have horizontal asymptote at y equal 2, and also the curve crosses and the point -2.3. And there is neither function, no symmetry, and the additional point we compute like that. Let me go to decimals now to see the process. See the process. To see the process. Let me see, guys. Okay. Wow. Now you share decimal. Do you see decimal now? Do you see? Do you see? Yes or no?
Yes, sir.
Yeah.
Yes, sir. We see it.
Okay, yeah. Okay, yeah or yes. Okay, now this was example 5, but we are doing number 6 now. Number 6 look like that. Look. You can see in green color 2.5, 0, and negative 1, 0 que represent the x in a set. 0, negative 5 represent the y in a set. This is the, we have no vertical asymptote, no. We have only one horizontal at y equal 2 is this line. And by the way, cross it, the curve, our curve is the blue curve, the point negative 2.3, 2. Entonces we plot in red color the additional point. 5, 1.15, 1, negative 3, and negative 3. Any question? Any question?
Not at the time, Professor.
Okay, perfect. This is exactly what we need. Okay, let's go. Let's go quickly now. One more problem, guys. Let me see. Okay. 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 Do you see the board now? No? Board,
Not
no?
yet.
Or board?
Not
Not
yet.
yet?
No, we just see you.
Okay. Let me try. Board now. There
It's
you go.
floating up, Professor.
Yes, now.
Okay, super. Okay, let's move on to an example number. This is number 6, 7, no, 5, 6, 7, no? 7, no? It's 7. I don't remember the name, the number. 7, no?
Yes, 7.
7, good. The name of this function is h. We have 2x squared plus 9x plus 4 divided by x plus 2. And we are doing step by step. Step 1, factorization. Factorization, let me try to do quickly in my way. Your multiplication, this number and this number is 8. 2 times 4 is 8. And the combination is 8 times 1 because 8 times 1 is 8. Multiplication 8 times 1 is 8. And addition 8 plus 1 is 9. If you convert this polynomial and this trinomial, and one polynomial like that. Because if you combine like here and here, a and 1 is 9, no? But I don't want to combine, no, because we come back to the original expression. No. I apply factorization by grouping now. Is there a common factor here? Of course, 2x. X plus 4. Is there common factor here? 1, x plus 4. X plus 4, parenthesis, 2x plus 4. And this is the factorization of the top part. So my factor form, this problem is x plus 4, 2x plus 1, and x plus 3 is just a binomial prime expression where we cannot do anything, and this is the factor. I can see. Is there common factor? No common factor. No common factor, that means if we cannot simplification anything here, it's because we have no hole. Good, I like it, no hole. The hole I don't like. The hole is the bad guy. Where's the next step? Where's the next step? Where's the next step? According to this guideline we state. Where's the next step? Tell me. You don't.
Y-intercept.
Exactly. And you always h and 0. When you always h and 0 is 2 times 0 squared plus 9 times 0 plus 4 divided by 0 plus 3. Answer is 4/3. And decimal 81 is 1.3 repeat. And the point is the point 0, 1.3. in decimal or a fraction, either way. Either way. What's the next step?
X-intercept.
Exactly. And the formula, remember, is this. It's out. Okay, this is equivalent. This is equivalent to say the top arc is P equal to 0. And P in our specific example is the polynomial. So it's x plus 4 times 2x plus 1 equal to 0. Therefore, x plus 4 is 0. That means it's x equal to negative 4 and 2x plus 1 equal to 0. That means it's x equal to negative 1 half. And the point are negative 4, 0, and negative 1 half. This is our excellent. Good, very good. What is the next step? What is the next step? What is number 4 step? I don't remember.
You got your
Vertical
X. You got your right.
Very good,
Vertical
very well.
asymptote.
And the vertical asymptote.
Exactly, and the formula is Q equal to 0, and Q represents the polynomial in the bottom, and the polynomial in the bottom is just x plus 3 equal to 0. Therefore, x equal minus 3. Okay, good. Now we have only one vertical asymptote at x equal minus 3. We can do that like that, no? This is -1, -2, -3, and we are doing a vertical line. It's the only vertical asymptote that have that. What is the next step?
Horizontal or slant?
Horizontal asymptote.
Exactly, or slant, no? And remember, to analyze this, you analyze the degree. Let me go over the original again, one more time. It's 2x squared plus 9x plus 4 divided by x minus 3 plus 3. So,
The highest degree is 2.
highest degree is 2, and highest degree here is 1, no? And when this situation happens, what kind of the asymptote we have, horizontal or slant?
For it to be that, it's going to be a slant. Not horizontal, slant.
Slant
You have one on the bottom, not on the top.
when the degree in the top is bigger than 1, the degree of the bottom. So 1 plus 1 is 2. So definitely we have a slant. We have no horizontal anymore in this example. No? And in order to find the slant, always we are doing long division or synthetic division. Either way, what do you prefer, synthetic or long division?
What's the fastest?
Well, the best, in my opinion, is long division.
Accurate.
Okay, listen to me. It's important that you understand this concept. Long division is more general. It's possible to divide any polynomial divided by any. It doesn't matter the degree. The degree is not important. But synthetic is a shortcut. It's only good when the degree of the denominator is 1. Here, linear. So it's easier doing synthetic division, but bueno, let's do it both ways, long division, synthetic division, long here, synthetic here. The long division is, you copy that, and you copy this. Es obvio que es 2x, right? So 2x multiplied by x is 2x squared, and 2 times 3 is 6x. By subtracting, change the sign. This is 3x. Bring down 4, and we keep going because it's plus 3 now. And 3 times x is 3x. And 3 times 3 is 9. By subtracting, change the sign. The answer is negative.
The question is,
Please, go ahead.
what's the first factor on the quotient supposed to be a -2?
No.
Well,
Okay.
how do you get
No.
-2x?
Let me explain. You copy exactly the same when you multiply 2x and x, 2x
You get
and x.
2x.
You give me exactly 2x squared. And this guy is this guy. Exactly the same, and you copy exactly the same. And after that, you change the sign by subtract.
Okay, that's what I was confused. Okay, now I understand.
Look. You divide 5 by 2. 2 times 2 is 4 by subtracting 1. Okay? You multiply this. No negative 2 is positive 2.
All right.
Okay? Super.
Gotcha.
Super. Now synthetic. Well, synthetic, well, synthetic you copy 2, 9, and negative 4, and 4, sorry. Without variable. Okay. And you copy 3, but negative. You remember that? And you change the sign one time. And that's it. No, here you change the sign several times. It's a chain. This case, no, one time. So you bring down to multiplication is -6, S3, multiplication is -9, and we get exactly the same remaining again, -5. Here, -5, this is -5, this is negative. But the answer is this. The answer is x to the 0 power, x to the 1 power, is 2x plus 3. It's exactly the same answer of this. Do you see very well now? Either way, guys, either way. The way can you prefer in the test? Either way. Super. So the conclusion, we have one slam, no? Slam. The slam is slam asymptote at y equal to x plus 3. Remember, slam is an oblique line. It's oblique line. Okay. Now ready to determine, for example, I want to do fast this part. Symmetric, not symmetric, unfortunately. Symmetry is special, no? The majority of the case is neither. It's no special. Neither is no special, no symmetric. How do you know quickly? Well, easy. Look, you know that when it's a square, stay the same. But when it's x to the 1, change. This stay the same, this is change, and it's a change. This is completely different sign. No, even, nor, or. Therefore, any. So I take different point to evaluate suppose a negative sign, arbitrary, totally arbitrary. In the specific interval, I want to investigate the function. Yeah, this is the easy part. Maybe it's long part, but it's easy. You plug it into the calculator, you get negative 4.5, you get negative 6, and you get negative 3.75. And you have 3 points, get the point negative 5, negative 4.5. It's a y value, x value, y value. Negative 2, negative 6. And positive 1, negative 3.7. And you plot that point, you plot the slant asymptote, you put the vertical asymptote. We have no horizontal, no, only slant. I go to Desmo to see complete the graph now. Yeah. Do you see Desmo? Do you see, right? This is example 7. Look at example 7. Let me make it zoom. In example 7, we investigate. We have one Let me see. This is 7. It's the same problem. Oh yeah. 0, comma. There you go. This is the x-axis. This is the y-axis. Look at that. Let me make it soon to see much better. This is the y-intercept 0.1.3 repeated, and we have 2, no? Is negative 1/2, okay, negative 0.5, 0, x-intercept, and another x-intercept, and negative 4. We have 2 asymptotes. This asymptote is vertical is at y equal negative 3. Here, look at that. And this is a slant. And the slant I represent like that, y equal to x plus 3. And this is the finally the additional point, get 3. Additional point, and additional point. And you have one acceptable idea how it look like the graph of the book. Any question? No?
Not at the time, Professor.
Okay. Guys, or you are super smart student, or I explain very well, or both?
Both.
Huh?
Both.
Oh, okay. The last topic, I want to introduce, because we have almost no time, is about the polynomial, and rational. It's the combination of both rational function, polynomial function, pero inequality. Okay? Let me start with polynomial first. This is rational is a little bit more complicated. Not today. Suppose we have this example. This is the like a motivation, no? Example. Introduction. In a guide example. This is the polynomial. Okay, already somebody knows. Eh?
You're still in Desmos.
Sorry. Now?
Yes.
Now?
Nah,
Okay.
yeah, we see you now.
Good. Okay. Thank you. You always save my life. Okay. The thing I tried to explain was, in this last topic, we study inequality. But these inequalities are special because in the left-hand side, we have polynomial, maybe, or rational. But in this case, we study today polynomial, no? Well, or at least the introduction to the polynomial. Okay, there are 2 different methods for solving this. One classical way, and another I want to explain in a few minutes. The classical way is, okay, this polynomial is greater than 0. To be greater than 0 means it's positive. So this possibility is this binomial is positive, this binomial is positive, or this binomial is negative, and this binomial is negative. This is the classical way. So you organize the job like that. Okay. To be positive is that x minus 1 is greater than 0, and x minus 2 is greater than 0. This is one possibility, no? Or we have another possibility is x minus 1 less than 0, negative, and x minus 2 is less than 0. Do you understand this statement? This is very, very complicated because we are using conjunction and, conjunction or. Remember when you study compound inequality, no? Compound inequality in 1033, no? It's the same, it's similar, no? Entonces, we working one by one. You working in this part. Let me call part 1. Is x minus 1 greater than 0. It's a synonym to say x greater than 1, and x minus 2 greater than 0. This is synonymous to say x greater than 2. And we're connecting both inequality by and remember, as intersection, I need to discover the common part that share this interval and this interval. So there are many ways to do that. However, I like so much doing graphical. This is the line can represent all real number. 0 in the middle, 1, 2. Get the number involved in the problem. Let me use a different color. For example, greater than 1 is something like that. And green color is greater than 2 is something like that. And the combination and in between this statement and represent the common. And the common I want to use a rainbow color is like, because the green interval is totally inside the blue, no? Therefore the connection is like that. Actually, this is equivalent to say that the connection x greater than 1 and x greater than 2 is equivalent to say just x greater than 2. And you can remove that part. Similar, let's do the second part, part 2, is x minus 1 less than 0. That means that x is less than 1, and x minus 2 less than 0. That means it's x less than 2. Exactly the same, we are doing the compound inequality graphically. The compound inequality graphic is 0, 1, 2. The first part is less than, so is the using blue color again. And this is less than 2. I'm using blue color now. In this case, it's obvious that the intersection between blue and green is just the blue part. X, change the color, x less than 1. And finally, the connection. This solution of the part 1 and this solution of the part 2 using OR. Now remember, OR is union. You put together without repetition. Let me try. Okay, again, one picture. Infinity positive, infinity negative. This solution is here. This is 0, 1, and 2. This solution is greater than 2. This solution is less than 1. Less than 1 is this. So you put together, but no intersection, a union. And union is addition, plus both intervals. Now the solution is then using rainbow color, something like that, to infinity, something like that, to infinity. Of course, do not include the endpoint, parenthesis, parenthesis. The solution is normally we represent an interval notation. Interval notation, the answer for the inequality is parenthesis from negative infinity, comma 1, parenthesis union, 2 comma positive. You see it's too long process. It's too long and complicated process. This is the classic. So I strong recommend, avoid this method. Only you can apply in one elementary example. We studied in the last class one fantastic way to solve it exactly the same. It is using critical value and testing point. But this is the next class. We have no time. Thank you so much, guys. I appreciate so much your attention. You are the best student in Miami-Dade I have. No, actually, really, this is my favorite class. Okay. Let me repeat again one more time the good news. The good news was that extending for the students that are late. I extended due date for both tests, September 29. Okay. Next class, no. Let me see. Let me see in the zero. September 24 is Thursday. I will send to you, boom, the test on paper. We have the entire weekend to do this. And also September 29 is Tuesday at midnight is due both. Is due the test on paper and the test online. Conclusion, September 30. September 30 is September 30 Friday, no? Friday. No, Wednesday. This Wednesday. Well, I wake up early in the morning and I grade your test. Okay? Maybe I finish or no, depending the time I have. I always post the grade in the Blackboard, guys. Okay, guys.